Hey, my name is Ethan Edwards, and this is my presentation on radar gun electronics. So, what is a radar gun? A radar gun is a device used to detect the speed of moving objects. A radar gun works by sending out a radio wave using a transmitter. That wave hits a moving object like a car or baseball and reflects back, is picked up by the receiver. The returning wave is slightly shifted in frequency depending on the object's speed. This is called the Doppler shift. Electronics inside the radar gun then compare the sent and received waves and calculate the frequency difference. They convert this back into a speed reading, which is what we see on the radar gun. Some applications are in law enforcement and in sports. So how does a radar gun relate to electrical engineering and what we have learned in the circuits class? Well, as you can see from the image I provided, there is some very sophisticated circuitry going on in this device. With a radar gun, you have to have power going to it to generate these waves. There has to be a signal processing within the unit, and it has to be able to convert this signal back into a readable number like miles per hour so that we actually know what the speed of an object is. So let's dive deeper into one key component that allows radar guns to work that also relates to what we've learned in our circuits course. As mentioned before, when a radar gun detects motion, it relies on the Doppler shift, which is a small change in frequency caused by a moving object. But the signal that comes back isn't clean. It's full of noise and unwanted frequencies, and that's where filters come into play. They're absolutely essential in making sure that the Doppler system works correctly and gives us correct readings. The first filter type used is an RF filter. This one only lets through the range of frequencies that we're interested in. It blocks out most of the irrelevant signals picked up by the receiver. Next, it goes through a low-pass filter. This removes the high-frequency components from the signal and allows us to isolate the Doppler shift, which is a lower frequency. This is what actually tells us the speed of moving objects. Finally, the signal goes through a bandpass filter. This cleans up the signal further by narrowing it down to a very specific range. This step fine-tunes the output and makes sure we're only looking at the exact frequency shift caused by the moving target, nothing more. Without filters, the radar gun wouldn't be able to tell what's motion and what's just background noise, so they're crucial for getting an accurate reading. One fun fact I learned while researching this topic is that radar guns function at the microwave frequency, which is the same frequency that a microwave operates at to cook our food.